As train technology has evolved, train track technology has had to evolve with it. Thus, rail lines have undergone various changes in order to keep up with modern trains. Rail lines have to be able to withstand a large amount of force without large amounts of deformation or failure. They also have to be able to withstand a generous amount of corrosion due to their constant exposure to the elements. Before the use of steel, iron was used in various compositions that had undergone many different heat treatments as methods were changed and progressed. Now it is most common for high-quality steel to be used to make rail lines, since the material is much easier to treat and manipulate so as to meet the requirements desired of train tracks. High-quality steel typically has a composition of about 0.8% carbon and 0.95% manganese. The chemical composition of the steel is balanced out so that it has a large tensile strength and hardness, but a low amount of ductility, as rail lines should not be able to bend and deform when faced with large amounts of compression or tension, or else damage may be caused to people or goods. This particular combination of materials was discovered after a lot of trial and error around the 1800s. Adding carbon to the steel makes it harder, but much more brittle. Adding manganese to the steel also helps with hardness, but it also improves the fatigue limit, improves corrosion resistance, and improves the surface quality of the steel to prevent cracking due to the lessening of embrittlement within the microstructure. The microstructure of such a steel consists only of perlite, and, when viewed from a microphotograph, it appears to be laminated due to the large amount of tiny lines within the photo, leading to the term lamellar. Perlite is formed by heating a eutectoid steel over 720 degrees Celsius and then allowing it to slowly cool. Perlite is actually a two-phase structure, composed of layers of cementite and ferrite. Cementite is extremely hard and brittle, greatly increasing the strength of a material, but it is found in lesser amounts within perlite than ferrite because of cementite's brittleness. Ferrite has a BCC crystal structure, making it more difficult for the atoms to slip, leading to less brittleness and making it harder for the material to break down or wear over time, which is necessary for railway tracks because of the loads they have to carry. The closeness of the lamellar within the structure also plays a role, as the closer they appear, the stronger the steel. The strength rating often ranges from 680 megapascals and 1,180 megapascals, while the hardness ranges from 200 brittle hardness to 390 brittle hardness, depending on the specificities of the heat treating process, such as time, temperature, and the cooling rate and process used to manufacture the steel before it is turned to rail lines. Some of the steel used to make rail lines is hot rolled and then allowed to cool naturally, which is a long process. This makes for a strong steel with low amounts of brittleness. Other steel is cooled quickly with water sprays after the material was heated to over 800 degrees Celsius, which is similar to the quenching form of heat treatment. This second method of heating steel makes it much harder but more brittle due to the rapid quenching of the outer layer of material that causes a stiffness within the bonds of the steel. All of these factors discussed serve to show the reasons for the treatments used so that the steel is as strong as possible without being brittle or deforming too much when loaded with a large amount of compression or tension. It also makes the material able to withstand a large amount of abrasion and temperature changes in order to make longer-lasting lines that will not defect and begin to corrode in only a year, as that would be entirely too costly if lines had to be replaced or repaired so often. As the years progress, it is likely that the material and the treatment of materials used to make railway tracks will either progress or become obsolete, depending on what direction the use of trains as a form of transportation and means of moving cargo progresses. Thank you for watching, and I hope you learned something about the heat treatment of modern railway tracks.